Okay, so today we're going to be taking notes on section 1.1, functions and function notation. And as you notice, I am using my phone and I don't have my super fancy prop. So it will be shaky, it will be messy, but you will get the point. The rest will be better. This is the first one, and unfortunately the first one is going to be booty cheeks, so I apologize. All right, so first thing we're going to do is we're going to talk about a function. What is a function? Now, I had some of you in 8th grade, we actually learned what a function is, and it hasn't changed. A function is a relation such that, I'm going to abbreviate that as T, for every x, or every input, there is exactly one output, which is y. And this is super important. It might even be a test question. What is a function? And you should know what it is. So again, it is a relation such that for every input x, there is exactly one output y. So every x, there is one y. That's what you got to remember. And we've actually done this before too. In order to test if something is a function, we use something called the VLT, which is the vertical line test. And so what it says is that if a vertical line crosses a graph at more than one point, so vertical line that's up and down, then it is not a function. So how can we go ahead and apply that? So we're going to use, these functions, these are graphs, right? And we're going to use them to the vertical line test to determine if it's a function. So how I'm going to do this is I'm going to just draw a line through here. So there's one vertical line. Notice that it only crosses at one point. All right, so far it's a function. So I'm going to draw another vertical line. Still crosses only at one point. I'm going to draw another one. Still only crosses at one point. These lines don't have to be in certain spots. I just need to be able to draw them and make sure that at any given point they're only going to cross at one. So because it only crossed this function here, here, and here, and each vertical line only crossed one, this is a function. Because it only crossed once. So moving on to the next one, we're going to do the same thing. And really quickly, you can see once I draw a vertical line through here, it intersects the function at two spots. That means this is not a function. And because these are my notes, I'm going to go ahead and make a note why it's not a function. It crosses two times. Okay, here and here. So if it crosses more than once, if it crossed 3 times, it would definitely not be a function. But if it crosses 2 times or more, it is still not a function. So this is not a function because of the vertical line test. This one is. Next, we're going to look at functions as tables. And so this is, remember, graphs tie directly to tables because they're points. So functions as tables, things to remember. Ooh, look, you can see how wrinkly my old hand is. Yeah, and I had popcorn. That's why there's butter underneath my fingernails. Anyways, functions as tables. Remember, each x has only one y. Okay, so how do we use that? I'm sorry, that was all crooked. Well, let's look at our input-output table. So here, I'm looking to make sure that each x has only one y. So if I look here, notice my x is 0 and it goes to 3. Okay, that's fine. But then here, x is 0 and it goes to 4. So these are different numbers. And because just that, those are different, these x's go to different y's, not a function. Okay, let's look at the next table. Here, 1 goes to 2, that works. -1 goes to 4, that works. -2 goes to 2. Notice that this output is different, or is the same for the input, but the x, for a function, it's each x has only one y. And so because -1, -2, and 1 are different numbers, this is actually still going to be a function. And then -3 is unique, so it's 4. So if you remember in 8th grade, we actually kind of looked at it as a shortcut to kind of see, what did we say? We said look for unique x's. And here, every x is unique, which means it's a function. Here, they are not unique. 0 and 0 are the same. That's why this is not a function. So this is a function, not a function. Yes. I'm going to make a note, unique x's. All right, 1-to-1. What is a 1-to-1 function? So 1-to-1 function is similar to a function. So first of all, if a function is 1-to-1, then it is a function. And every y has exactly one x. Okay, so in this one, every input has exactly one output, and every output has exactly one input, so it maps itself back and forth. And to test if it's a 1-to-1 function, we use the HLT, which is the horizontal line test. And the horizontal line test says that if a horizontal line crosses a graph at more than one point, then it is not a 1-to-1 function. So we're going to do the same thing. This time, instead of drawing vertical, well, actually, let's draw a vertical line first. We're going to draw a vertical line first to see if it's a function, because it needs, if in order for it to be a 1-to-1, it needs to be also a function. So if I test it, look at that. Already not a function, so not a function. It doesn't matter if it's 1-to-1 here, because it can't be 1-to-1 without being a function, right? It's like saying, I am Miss A, right? But I'm not a human. So I couldn't be Miss A if I wasn't a human, right? You have to test to see I'm a human first, all right? Same thing with 1-to-1. This needs to be a function first. So we're gonna do the same thing here for B. We're gonna test to see if it's a function. And this is something you should be able to eyeball, but we're gonna draw the vertical lines so you have a visual. And so far, it is a function. It is a function. And now we're going to test to see if it's 1-to-1. So remember, this is where I'm going to draw a horizontal line. So it only crosses one time here, so that's good. But then here, it's going to cross 1, 2, 3 times. So not 1-to-1. Okay, is a function, but not 1-to-1. Finally, for this one, vertical line test, it passes. So is a function. And then horizontal line test, it's also going to pass. Only crosses in one spot with my horizontal lines. So, and 1-to-1. I'm just gonna write 1-to-1 because I'm getting lazy. Okay, so next part, this part right here has to go with the next function. So we're kind of done talking about vertical lines, func test, horizontal line test, whether it's a function or 1-to-1. Now we're going to talk about evaluating versus solving. So if we're evaluating a function, we're really asking that question, what is f of a? Okay, so if it's you're solving for f of a equals b, that's when you are evaluating. In other words, you are finding what is y when x equals a. Okay, so when you're evaluating something, you're really trying to find out what is the y value. When we are solving something, we're still looking at f of a equals b, But this time we're looking at it in a different context. When we're solving a function, we're trying to find out what is x when y equals b. Okay? So if you're asked to evaluate something, you're finding the y value. If you're asked to solve something, you're finding the x value. So that's how these two are different. Okay? So trying kind of like giving you a quick check. Math is its own language, and this is how you start to interpret that language. Okay? So let's go to the next page. Yes, we do have 2 pages of notes. Notice how they're not terrible. All right, so here, the first way that we're going to learn how to evaluate functions and function notation is by looking at a graph. You should be very fluent in this right now, so let's get to it. I'm asked first to evaluate f of 2. Now remember, evaluate means I'm trying to find what is y. So f of 2, if I look to where y is 2, looking for x is 2, x is 2 right here. So this is f of 2. Now when x is 2, y is 0. So f of 2 equals 0. Again, I'm looking at that point on the graph. That's the point 2, 0. Let's make a note of that. 2, 0. So when x is 2, y is 0. So f of 2 is 0. That's how you can interpret that problem. Let's do the same thing. This time we're solving for f of x equals -2. So here I was finding y when x was 2. Here I'm finding what is x when y is -2. So I'm looking at my graph. Y is -2 right here at this point. So here, this is the point 3, -2. So at the point 3, -2, f of 3 is equal to -2. That gives me the point 3, -2, which means x is 3. Because when x is 3, y is -2. So that's how we do it with a graph. Tables are actually kind of easier. So for tables, I'm evaluating f of 2. I'm looking when x is 2, what is y? When x is 2, y is 2. So f of 2 equals 2. Here, f of x is equal to 3. So going backwards, I'm trying to find the x value. Notice how x is there when y is 3. And actually, this should be h of x. Notice that I have different variables here. We're going to pretend like that's an h. So looking here, h of x. And of course, I mixed up my colors. It's going to bother me, which means it will bother you. So changing that to green. Pretend like that was never blue. All right, now we're going back to green. So x, y is 3. Right there, x is 0. So f of 0 equals 3, which means, you guessed it, x is equal to 0. Ooh, so now we have another question. Is the function h of x, that guy, 1 to 1? So remember, it's 1 to 1 if for each x there's exactly one y. So every x there's exactly one y, so we know it's a function, but then also every y has to have exactly one x. And notice that I have duplicates in my y's here. That means this is not a 1-to-1 function because of this guy and that guy. Nope. So not 1-to-1. Okay. Evaluating functions. So then finally we're going to look at it when we're given an equation. So given that k of x is equal to x squared plus 1, we're going to start by evaluating k of -1. And really, I'm just trying to make sure you still remember how to work with exponents. So if k is -1, then what that means in an equation, since I'm trying to find the y value, I'm just going to replace all of the x's with -1. So k of -1 is equal to -1 squared plus 1. -1 squared plus 1, that's the same thing as a 1 plus 1. Why is it 1 plus 1? Because -1 times -1 is positive 1. And finally, 1 plus 1 is 2. So k of -1 is equal to a 2. All right, now solving k of x equals 5. This is different. This time, I am replacing the k of x with 5 and solving for x. Remember, my goal is to solve for x. So I'm going to say 5 is equal to x squared plus 1. I just did that little substitution. Now solving for x, I'm going to subtract 1. So now I have 4 is equal to x squared. Fun fact, when you solve for a square, remember you got to take the square root plus or minus of both sides. Square root of 4 is 2. So x is equal to plus or minus 2, and that's your solution. Okay. All right, last little bit, word problems. So this is application problems, and so these do come up. The function n equals f of y gives number of police officers n. So n represents the number of police officers in a town in year y after 2000. What does f of 5 equals 30? So the way I like to break this up is thinking about what each one represents. So the 30 corresponds to the n, which remember is number of police officers. So this means that there are 30 police officers, right? That's what the 30 represents. That's what the n represents. Next, I'm going to look at the y. Y is year after 2000, and that's given to us by 5. So 5 is years after 2000. I can think of this as 2000 plus 5, which is the year 2005. So in this scenario, what does this problem say? This problem says that in 2005, a town has 30 police officers. And that is what f of 5 equals 30 represents. All right, write a summary. It helps summarize your notes. Obviously, that's what a summary does. But it'll help you kind of make sense of it. So, have fun. See ya.